All right, so we are going over the warm-up now. The first function, the parent function, is what? Y equals what? X cubed? Okay, so the parent is y equals x cubed. That's a good thing to keep in mind. You want to have the right parent function in there. All right, normally the parent function would have a center point at 0, 0, but it shifted which direction? To the right. So the transformations are right, 1. Are there any other transformations? Can anybody else find another transformation? Is it flipped? No, not reflected. Is it stretched? Do you guys remember the parent function would go over 1 and up 1? Does it have that? It's up 3. So how do we show a stretch of 3? Yes, 3 times. Very good. Okay, so we're going to have y equals 3. And then the parentheses, x, and should it be plus 1 or minus 1? X minus 1, we'll move it to the right. And then what am I missing on my equation? A cube, that's right. So a lot of people forget that the parent function has to be included too, the cube right there. Okay, your domain was negative infinity to infinity, and how about your range? Also negative infinity to infinity, which is the same as all real numbers. Good. All right, next one. What's your parent function? Y equals square root of x. Very good. Okay. Which way did it shift? From 0, 0, the start point shifted which way? Down 4 and left 1. Anything else happen to the square root? Which way is it reflected, guys? Over the y-axis. It's reflected horizontally. Okay, so I have a y equals, and I have a square root. Now, when you have a horizontal stretch or a horizontal reflection, that happens on the inside. And you need to actually have that factored out. So if you don't have a parentheses there, you want that parentheses. So the negative's on the inside, it's factored out. And then to shift left 1, I need x plus 1. And then down 4 is minus 4. All right, so that right there is important, because if I distributed that, I would actually get negative x minus 1, which I don't think is on anybody's paper, right? So keep it this way factored out. Look at your neighbor. Make sure that they're following that. Okay, your domain starts on the left. It's negative infinity up to what number? Negative 1. So negative infinity, comma, negative 1. Does it matter what order you put those numbers in? Yes. Guys, domain and range should always be smallest to largest, so you can't change those numbers. And then your range starts at what smallest value? Negative 4, and it keeps going until positive infinity. Okay, questions on 2?
Negative outside the square root that's reflected across the x, right?
Correct. Yeah. All right, guys. Parent function is y equals what? 1 over x. Now, normally your asymptotes would cross at 0, 0. So that point where the asymptotes cross, it shifted which way? Left 2, down 3. Now the point on the graph is over 1 and down 1. That's the normal point, over 1 and up 1, except that these branches aren't in the right places. Normally we would expect our branches on the top right and the bottom left. So what can we do to change them here? Anybody put anything on their function that shifted the branches here and here? A negative, yeah. So for the equation, we're going to have y equals, you can put a negative in front of your fraction or you can put it on your numerator. Either one's fine. Negative 1 over x, and then to move it left 2, what should I put with the x? Plus 2. And then after the fraction, minus 3. Okay, so that negative can be in front of the fraction or it can be on the 1. Okay, your domain is everything except for this asymptote, right? To negative 2, and then negative 2 to infinity. And your range is everything except this asymptote. Yes.
So you use the parentheses when it doesn't include the number?
Mm-hmm. Did you guys hear that, guys? You use the parentheses when you're not including the number. So here, go ahead.
And then the bracket when you do.
Right.
Okay.
So I did want to include this endpoint here, so I used the square bracket, and I didn't want to include the asymptote, so we used the parentheses. So if that is something that you didn't know yet, write that in words on your paper and you'll have it to study. Use the parentheses when you don't want to include the number. Use the square bracket when you do want to include the number. All right, so we're going to do a quick review of graphing lines. Do you remember y equals mx plus b? Y equals mx plus b? So the b was your y-intercept. And the m is what? Slope, good. So my y-intercept is 1, graph the 1. And this is not a fraction, so I can make it a fraction by putting it over what number? 1. So 2 over 1 is the rise over run. Up 2 and over 1. And you can do that more than one time if you want to get a nice straight line. You can use your student ID as a straight edge. Okay, beautiful. All right, so take a minute and see if you can do this review of graphing lines with your group. I'll come around and see how you're doing, and we'll go over them in a couple minutes. Okay, for this one, your y-intercept is negative 4. Your slope is negative 1 over 1. So you should have this line. This one, your y-intercept is 2. Your slope is up 2 and over 3. Oops. Guys, tell me when I'm off the screen. So far, so good? All right, Greg, next one. What's your y-intercept?
4.
This one.
Plus 5.
So starting at 5. And then which direction did you go from there?
It's inclining towards the left.
Okay, so how do I know where to put my next point?
You go up 1 to the, no, down 1.
Like that?
Yes.
Okay. Okay, Colleen, what kind of line did you get for number 5?
For 5?
Yep.
It's just like that at 3.
Okay, did anybody else get a line like that at 3? Good. What's the word for a line like that? It is straight. All lines are straight. Horizontal, very good. Okay. So all the y values on this line are 3. All right, and what kind of line do we get for the last one?
Vertical.
Vertical, very good. On this vertical line, all of the x values are -1. Am I off the screen?
Yes, you are.
Thanks. Okay, are we good on graphing lines? What questions do you still have on graphing lines? All right, the reason we're graphing lines is because we are going to put some lines together today to make piecewise functions. This is what piecewise functions might look like. You see how you have more than one piece of a function? So we're going to do the domain and range of these piecewise functions. I need to see that you are all ready. I'm waiting.
I'm ready. I think so.
Waiting for one more group. Okay. All right. To do your domain and range, I like to use my pencil as a scanner to figure out where to start and where to stop. Domain starts on the left, and it goes to the right. So what's your smallest x value on the left? Is it -6 right here? Okay. Do we include -6?
Yes.
Yes, it's colored in, so we're going to include it. Okay, we continue over to what number over here? Now, I only want to stop at 1 if there's a break in the domain. A break in the domain means there's a number I have to leave out. Do I have to leave 1 out of the domain? No. If this was an open dot and I had 2 open dots, I would have to leave it out, but I don't. This dot means everything except for 1, which I already have 1 here. So I'm going to jump up to this piece, and I'm going to keep going to this number here. What's my x value for this number? 5? Okay.
Would back up that if it was like there was one that was open and one that was closed, the open one like takes over.
Okay. So I haven't heard that before.
Like we did it over here, and there was like a top thing, and on the bottom there's something else, and it was if one of them had like it went to a certain, it was like infinity, but then the other one had line step or whatever it is at like 3 or something like that. So we took out 3.
Okay.
So if there was like that there, like that's not.
So Ellie's remembering another problem, and I'm not remembering that one, but maybe if you can draw me a picture of it, then I can try to clear that one up. In this case, we're just talking about what x values are on the graph, right? So -6 is on the graph, and all the numbers after -6 are on the graph. And 1 is on the graph, right? It's like right here.
Over there, it's not.
I get that, yeah. So,
Do you still put it on the graph?
yeah, because 1 is on the graph somewhere. So if 1 is on the graph anywhere, then you want to include it. And then you keep going after that. Let's look at your range now. Your range is a little confusing because there's some overlap. Do you see how like right here, there's 2 different y values? You're only going to list it once. So what's your smallest y value? -3 is your smallest y value. And even though there's a hole here, do we cover that y value right here?
No.
Do I have to leave 1 out of the range? Let's look over here. Is 1 covered by this function?
Yeah.
It is. Like it's defined right here. This is a defined value where y equals 1. So we do want to leave 1 in the range. We keep going up. This one stops right here. But do we have numbers in our range that are bigger than 4?
Yes.
Yeah, so we're going to keep going to our biggest y value, which is what number? 1, 2, 3, 4, 5, 6. Our biggest y value is 6. And we're going to include that. Okay? I'm going to do this one with you, and then I'm going to let you guys work on 8. Any more questions on 7? I'm going to come back to see if I can see what that picture looks like that Ellie was describing. Okay, for this one, your domain has an arrow on the left, so that means your domain starts at what value? Okay, on the left over here is -infinity, so it starts at -infinity. And then it keeps going until this piece right here. So that's -2. Is negative 2 left out of my domain? Yes, I have a hole on both of the pieces, so I have to leave negative 2 out. Okay, and then it keeps going, and it keeps going, and this arrow is going to what value on the right? Infinity. Now guys, remember, domain is all about the x values, so I'm talking about left to right. A lot of people want to call this negative infinity because it's going down, but that only has to do with the range. On the right side, the x values are going to positive infinity. Bless you. All right, our range starts at the bottom, so you can use your pen like a scanner again. Starting at the bottom, what y value is there at the bottom? Negative infinity. So my range starts at negative infinity, and I'm going up, and I have this gap in here, but is that gap covered by anything else? Look over here.
Yes, it is.
Yeah, see, there's no gap in my actual range because these values here are covered by this. But it does keep going up until what maximum y value? Is that 6?
Yes, like 6.2.
Yeah, Kieran wants to call it 6.2, and that's fine. You can call it 6.2 because it kind of looks like a little bit more than 6. I think it's intended to be 6, so I'm going to put 6. But if you put 6.2, I would not count you wrong. I would say look at that attention to detail. Okay, so I'm going to give you a minute to try to do problem 9. Okay, domain starts with this arrow over here. What's your x value over here? This is negative infinity. It continues until the x value right here. Do we include negative 1? Yes, because of the closed dot. And then we do actually have a break in our domain until 1. Goes to 6. Is it 6 over here? Do we include 6?
No.
Don't include 6 because of the open dot. I thought the range was kind of tricky though. What's your smallest y value? Negative 4. Make sure you include the negative 4. Unless you see a hole or an asymptote, you want to include it. It goes up, it goes past this gap because notice it's covered over here. So as you're going up, there's still y values. Does it stop right here?
No, because the other line on the left.
All right, so look, Greg points out, look at this one. Even though this part of the function stops here, where does this one stop?
No, it doesn't.
It doesn't stop. It keeps going all the way past. Okay? So when you see those arrows and you're doing domain and range, it can help you to make those arrows even longer so you can watch the line past that hole there. Okay, so we keep going all the way until infinity. Questions on the domain and range? Okay, we're going to do some piecewise functions, and it can help to have different colors for your different pieces. So if you have colors, you can take those out. All right. Piecewise functions, we're going to put more than one function together. Now I can't just have 2 lines. I can't just have y equals negative 4 and y equals positive 2 on the same graph because it does not pass the what test? It does not pass the vertical line test. Okay, if a vertical line crosses 2 points on the graph, then it's not a function. So the way we account for that is we define part of the graph when x is less than 3 and part when it's greater than or equal to 3. So I'm going to find 3 on my graph here. This is my changeover point at 3. Now, I'm going to actually start with my pencil because what I do for piecewise functions is I graph the whole thing and then I erase the part I don't need. So y equals negative 4, that's down here. I'm going to graph the line y equals negative 4 with my pencil because I'm going to be erasing part of it. Oh, thank you. Okay, here's y equals negative 4. But I only want y equals negative 4 when x is less than 3. So I'm going to put a hole at 3. And I want the part when x is less than 3, so that's over on this side. So what I'm going to do now is use one of my colors to graph this line, only the part when x is less than 3. And the other part I'm going to erase. So the first function is y equals negative 4 only when x is less than 3. So that's here. The next one is y equals 2. So I'm going to graph y equals 2 with my pencil. And I only want to keep that when x is greater than or equal to 3. So here's the or equal to part. I'm going to color in the circle. And here's the part when x is greater than 3. So I'm going to keep that, and then I'm going to erase the rest. Yep. And then just to remind me which is which, the pink is this one, and the purple is this one. Okay, what questions do you have on that? So I'm going to do 11 with you, and then I'm going to do one that has more pieces to it. I think I'm going to do 15. And then I'm going to give you some time to work on the others. Okay, so in 11, I have y equals x minus 2. So what's my slope for y equals x minus 2? 1, yep. So my slope is going to be 1 over 1. So start at negative 2 on the y-axis. Do a slope of 1 over 1. And the important number for this one is negative 1. Negative 1. See, that's where we switch over at negative 1. So I'm going to actually keep going backwards with my slope. And graph that line, graph the whole line, and we'll figure out which part we want next. Okay, did you graph the line yet? I'll wait for you. So we only want this line when x is less than or equal to negative 1. So x is less than or equal to negative 1 is over here on the left. So we're going to keep the left and we're going to get rid of the right. Okay, less than or equal to, solid dot. Okay, the next one is 3x plus 2. I'm going to make the 3 into a fraction by putting 3 over 1. I'm going to start at positive 2 and do a slope of 3. And it does help to do your slope backwards as well. Okay, so graph your line. I'll wait. Yes.
Why is your first one at negative?
Say it louder.
Why is the first one made
At negative 3?
Is it at? I can't see.
Here, let me see if I can zoom it. So I think you're talking about the y value. The
Yeah.
y value is negative 3. The y value is just what it happened to be. It's the x value that I'm paying attention to. So it says x is less than or equal to negative 1. So I went to where x is negative 1, and that's how I chose that part. All right, the next one says x is greater than negative 1. So at negative 1, I need an empty dot. And then I'm going to use a new color for that one. All right, what questions do you have on that? Okay, we're going to do one more together, and then you guys are going to work on these. We're going to do the last one, number 15. So let's go to the last problem. We have 3 lines, so it's just a little bit longer. First one, y equals x plus 3. So put in a slope of 1 over 1. Start at 3. Do your slope in both directions. Okay, last problem on the page. We just graph the line y equals x plus 3. We want that when x is less than -2. So I'm going to mark -2 on the number line here. -2. And just less than, not less than or equal to. So what kind of dot do I want? Open dot. And x is less than 2. Will that be to the left or to the right? To the left. Good. So keep that part, erase the rest. Are you ready for the next one? Okay, next one, 2x plus 1. Make the 2 into a fraction, 2 over 1, and start at your y-intercept 1. Up 2 and over 1. Here's your line. And we want this line if x is greater than -2 and less than or equal to 0. So 0 is an important point on my number line here. Okay, so at -2, do we have an open dot or a closed dot? An open dot at -2. And at 0, do we have an open dot or a closed dot? Closed dot at 0. And so we want the values in between that. So we're going to connect those 2 dots. And then get rid of the rest. Okay, if you're ready, you can graph the next line. Okay, I'm going to make my slope -3 over 1. Start at 5 on the y-axis. And do a slope of -3. And we want this when x is greater than 0. So x is 0 right here, but we don't want to include that, so we're going to put an empty dot there. And greater than 0 is going to be here. Okay? All right, what questions do you have? Okay, so I'm going to give you a few minutes to work on 12, 13, and 14, and then we're going to compare your answers with each other. Okay, in problem 12, y equals x plus 1 is this line right here. You only want it between x is -4, that's right here, and x is +2, which is here. Y equals 1/2 x starts at 0 and goes up 1 over 2, up 1 over 2, but you only want it between 2 and 6. Make sure you have the open dots here and here, like Annabelle does, and the closed dots here and here. What questions do you have on 12? All right, checking your work for 13 next. 13, you have y equals 2x minus 2. That's this line right here. And you only want that when x is less than or equal to 3. So here's where x is 3. And this is the less than or equal to. Negative x plus 5 started up at 5, but you only wanted the part of the line when x is greater than 3. So you marked the open dot at 3, and you only kept this part. What questions do you have on 13? Okay, number 14 had 3 parts to it. Here's one thing I noticed from a lot of people. You didn't know if you wanted to make this point here open or closed. So if it's colored in for either function, you color it in. Okay? Is that okay, Courtney? Okay.
Yeah, no.
You look like, no, I don't think so. So if it's colored in for either function, color it in. So don't leave it both colored in and not colored in. Don't try to like give me some sort of hybrid. Okay? Just color it in. So you had the first function here, the second function here, and the third function is here. Do you have any questions before we move on? Okay, we're going to move on to the next page.
On the test or quiz, what would you please use colored pens for it?
Sure, I love different colored pens on tests and quizzes. I sit at home and I can grade them and it just makes me happy. I just have a question. Hang on one sec. Let me give Annabelle. Did you guys decide to find f of negative 4, which function we're going to put it into? First, second, or third? Tara? Anybody else think first? One person, 2 people. Anybody else think first? Okay, that's a few more. Okay. Anybody think it's a different one? Okay, so Tara, why do you think it's the first one?
Because it has to be less than -2.
Okay. So it says if x is less than -2, use this function. Is -4 less than -2? Yes. So since -4 is less than -2, we're going to use the first function. So f of -4 is going to equal 3 times the square of -4 plus 16. Did you guys figure out what that is yet? What's the square of -4? 16. 16 times 3.
48.
Thank you. And then 48 plus 16 more.
64.
Thank you. All right. So f of -4 is 64. Next one says find f of 11. So look at your function again, f of 11, and decide which part of the function we're going to use for f of 11.
The middle one.
Okay, I heard a couple votes for the second or the middle one. Anybody feel strongly it's the second one? Raise your hand. Okay, let's go back and see. It says to use the second one if x is greater than -2 or less than or equal to 11. So it is equal to 11. Very good. Okay. Since 11 is less than or equal to 11, we're going to use the second function. Okay, and we're going to do f of 11 is the square root of 11 minus 2, which gives us what? Okay, square root of 9, which is 3. Very good. Okay, so as long as you know which part of the function to look at, that kind of question should be very straightforward. Okay, writing the equation of a linear function. So to write the equation, you just want to use the m and the b. So let's find the slope and the y-intercept. So the slope, remember, is your rise over your run. So you want to find 2 points that are on your line, like here and here. And what's the slope of this line? Rise over run. Up 1 over 3. The y-intercept? Oh, thank you. Y-intercept, where does it cross the y-axis? -2. So when I write y equals mx plus b, I'm going to have y equals 1/3 x minus 2. Good. All right, try b.
Y equals 2x.
Close.
How's it not right? Because it's right, if your eyes on the run, it's 2. Because you have 2 over 1.
Are you using this point and this point?
Yes.
Is your rise positive or negative?
It's negative.
All right, so what's your slope, guys?
Negative 2.
-2 over 1, which is just -2. And what's your y-intercept? Okay. So the equation? Let's. Okay, so I heard y equals -2x plus 0. Is that correct? Y equals -2x plus 0?
Yes, but it isn't the revision.
Okay. So y equals -2x plus 0 is perfectly right, but most people would then simplify that to be y equals -2x. So the reason why we have to be able to write the equation of lines is because we need to be able to write the equations of piecewise functions. So let's look at number 18. Number 18, how many pieces do we have? 3 pieces, very good. So what I'm going to do is write the equation of each piece on that piece. In order to write the equation, it's helpful to know your y-intercept, so I'm going to extend this one so I can see where my y-intercept is. Y equals, what's my slope? What's the slope of that piece? Okay, so I heard -1 over 2. What do you like about that slope, guys?
Oh, just 1 over 2.
Okay, so she likes the 1 over 2 of her own slope, and then she made it positive. Do you guys agree that this is a positive slope?
Yes.
Yes, so you read it from the left to the right, and if it's going uphill, it should be a positive slope. So she says the slope is 1/2. And then your y-intercept, you see how I extended the line to find my y-intercept? So I have y equals 1/2 x plus what? Plus 3, yeah. All right, this one is straight across at y equals what number? 2. And then this one we can extend also to find your y-intercept. Does this last line have a positive slope or a negative slope? Negative, okay. So y equals negative, what's the slope? -1 over 1. So I could write -1x, or I could just write what? -x plus 3. Okay. Now I'm going to erase the extensions that I made because it's going to confuse me when I'm trying to figure out what my restrictions are on the domain. So f of x equals (1/2 x plus 3) if x is greater than or less than? If x is less than what number? -2. Yeah, you see it right here? Now should I include the -2? It's definitely colored in here. You want to include it with one of your functions, okay? So you can decide if you're going to include it with this one or the next one. I'm going to include it with this one to make sure I got it, and then the next one I'm going to leave it out. F of x equals 2 if x is between numbers, right? So actually, I should put x in the middle. Okay, what numbers should I put it between? starting at what number? -2 all the way up until 1. So if x is between -2 and 1, okay? So notice I didn't include the -2 because I had already included it on this one. You only want to include it on one of the functions. And then I included the 1 here, so I won't include it here. So then it's going to be -x plus 3 if x is greater than what number? Oh, no, it needs to be between again, doesn't it? If x is... Okay. If x is greater than what number? 1 and less than what number? The 3. Good. Okay. I'm going to give you guys a minute to try this challenge before we do the ones on the back. Okay? How many pieces do you see? 3 pieces. So work on that. Work together with your group. I'll get back in a minute. Okay, so let's see how Diego did this problem. He had -1/2 x plus 4. So there's the 4 and the slope of -1/2. If x is less than or equal to 2, that's right here. He has the parabola x minus 3 squared plus 2. So that shifts you right 3 and up 2. Doesn't have any stretch to it. If x is between 2 and 5, so 2 to 5, you have to leave 5 out. Actually, you had this right, and I had you change it. You had to leave 5 out. So he had that right. You have to leave 5 out because of the hole right there. So you don't want any equals on that. And then x plus 1. Some people had a hard time figuring out what the y-intercept is, but if you do extend your line all the way down here, you can find that your y-intercept is +1. So 1x plus 1 if x is between 5 and 7. Do you guys have questions on 19? It's trickier when it's not just lines, but you can put this together. Put together what you know about transformations with what you know about piecewise functions. Okay, and you can expect piecewise functions on your quiz next class. All right, can we move on? We have one more thing on the back. Here is a function, and we don't know the name of the function. We're just trying to figure out how that function changed. So look at the parent graph on the top. This is the parent graph. How do I move this parent graph to make it look like this one here? Okay, I heard flip it over the x. So if I flip it over the x, does it look like that? Let's see. This 2 would be here. This 1 would be here. So it would be like this. And then this point would be here. It would be like that. So does this look like this? Okay, so flipping it over the x worked here. Let me go up a little bit. So reflect vertically. Okay, so if I'm reflecting it vertically, I'm going to have a negative on the outside of the function. Now remember, I don't know what this function is, so I'm just going to call it f of x. So if I reflect it, I have a negative on the outside of the function, y equals negative f of x. That's it. Whatever f of x happens to be, like x to the third plus x squared plus 2x plus 2, whatever it happens to be, I'm going to take the opposite of that. So I just stuck the negative out front. All right, next one here. How do I get from my parent function to this one right here? Okay, I heard that it moved up 2. I see that like that. But maybe that up 2 is taken into account by something else that happens. What else happens? It's stretching by 2. Can you see how the distance between here and here is a height of 2, but over here it's going to be a height of 1. So this one is stretching vertically by 2. And that's going to take into account this that looks like an up 2 as well. Go ahead.
And those stretched up to, wouldn't it go up to 3 on the y-axis?
Go up to 3 on the y-axis. Well, this distance between them stretched. So everything in the function is multiplied by 2. So this point here that was at 2 is multiplied by 2 and is at 4. Okay, and what happened in the last one, guys? Up 2 and it reflects? So this point right here is matching this point right here. Is that what you're saying? Those are the same point? So if I reflect it horizontally, and then I shift it up how many? Up 2. Okay. So reflecting horizontally happens inside the function. So instead of negative f of x, what am I going to have? F of negative x. F of negative x is going to reflect it horizontally. And then up 2 happens outside the function. So what should I put here? Plus 2. So this is just a different notation when you don't know what function you're dealing with. This is the kind of notation that you would show your transformations on. Okay? All right. So I would like you to use the few minutes we have before the announcements to start on the homework so you know what your questions are, and you can ask me and you can ask Mr. Simpson. And remember that you have a quiz next class. If you have any missing homework, you probably want to do that homework to make sure you understand everything that's going to be on the quiz.